today we'll start with learn about PAV, which is pressure aging vessel. So as we discussed in last RTFO class, we know that unaged bitumen, right, which is a virgin bitumen without any aging, we give it to bitumen refinements. So next, when we go to the stage of production and construction, the bitumen undergoes short-term aging, which will simulate the laboratory using RTFO method, right? What we discussed in the previous video. Now this RTFO aging is mainly due to something called as volatilization. Right? So whatever the particles are there, the volatile components, they will escape from the bitumen, and the bitumen slightly gets harder compared to the unaged bitumen. So if you see the previous RTFO videos, so we saw that the PG8210, almost the viscosity was 10 times the unaged bitumen, right? This way the viscosity will increase from when we go from unaged to RTFO bitumen. Now this happens during the stage of production and construction stage. Further, as we move further, when we lay the bits and allow it to operate or allow it to serve, so what happens? It will be in service condition. So it will be serving the vehicles as a pavement now. So due to this, what happens? It is exposed to the oxygen and air and other abating factors. In this stage, it undergoes something called as oxidative aging. This oxidative aging is a slow process, right? It will continue for years and years. And by the end of the service life, the bitumen will be very hard. It gets very hard due to loss of different components and due to oxidative aging. Now, to simulate it in the laboratory, what we do? We use pressure aging vessel. Now, this PAV or the pressure aging vessel will simulate the long-term aging, right? Which is expected to be simulating condition of around 15 to 10 years, right? So though there is no particular time limit for this method, right? It is 15 years, 10 years, 5 years. Normally there are some specifications to be followed to obtain the PAV aging bitumen. So we will see what is this pressure aging vessel and what are different components, right? So we will see what is PAV. Now, this is a whole set of different components of pressure aging vessel. So now this is the main thing, which is the pressure aging vessel, where the bitumen will be subjected to high pressure and also high temperature. This will be try to accelerate the aging process by applying high pressure and high temperature. Try to accelerate the aging process within a particular time in the laboratory. So this is the PAV vessel, and this is the gas which supplies for the aging purpose. Since we hold plus some pressure, supply the pressurized gas for the aging purpose. And this is sample plate, right? So this sample plate, and this particular pan is a pan on which we pour the bitumen. On this we pour the bitumen which is RTFO agent. So it's step process: first unaged bitumen, then RTFO agent bitumen, and then we'll age for PAV. So whatever you age for RTFO, you will pour in this approximately 50 grams. Right? It says PG30 working on. First age RTFO is the PG30, then pour 50 grams in this particular plate. Right? So then this is the degassing chamber. Now this degassing chamber is mainly used to remove the gases. So when we apply for pressure and this is temperature, there is some air bubbles in the bitumen. To remove those air bubbles, remove this degassing equipment. So it works as vacuum principle. So we will see each component individually, and we will see what parts are there in each component. So this is the PAV. So this is a lid, and if you see this, this is the pressure aging vessel. So you can see how thick the particular chamber is, and this plate is very heavy because inside this chamber we will apply a pressure of around 2.1 megapascal. So you can imagine it's a very high pressure. So this vessel should be able to sustain that pressure. So we'll apply this 2.1 MPa pressure, right? And this, so it's very heavy also. So this is a particular chamber inside. So you can see how thick this particular chamber is. You can see here two sensors here. One is this thermal sensor, this thermocouple to sense temperature. So this particular temperature chamber sensor, and this is the pressure sensor. We'll apply a pressure of 2.1 megapascal. So in this whole chamber, we'll keep this particular bitumen tray. There's a bitumen tray, so we will keep like this inside the chamber. Yeah, we'll keep like this fashion, and then we will close this particular lid, right? We will keep and close it. So this way, once you close this lid, we will apply pressure of 2.1 megapascal and set to a temperature of 90 to 110 degrees. So in that range you will allow it to age for at least 20 hours. 20 hours you will age, right, for this particular bitumen. That means 20 hours it will be subject to a pressure of 90 degrees to 110 degrees and a pressure of 2.1 MPa. So in this condition it will undergo accelerated oxidative aging. So where it will lose lot of components, right? So it will undergo both physical and chemical changes. So once you get the PEV bitumen, you can study the bitumen both physically and chemically what changes have been happened after PAV aging. So basically we are trying to simulate a long-term aging. This is a typical PAV aged bitumen here. So obviously this is very hard compared to the RTF aged bitumen because it is undergone more aging compared to RTF aged bitumen, right? So this is how the PAV aged sample after aging looks. So once you test the properties using either penetration, softening point or dynamic shear limiter, we can determine how much aging has been happened or how much the properties have been changed. It can be viscosity, it can be penetration, it can be softening point or any other property, right, pertinent to the bitumen. So it will change after doing the long-term aging. So once we do this long-term aging, what happens? Basically, this bitumen, when you apply the long-term, this particular PAV vessel, so it will be quite very liquid, right? And it will have some gases also. Now, this gases must be removed. To remove this gas, immediately we will transfer for this vacuum degassing chamber. This vacuum degassing chamber will apply a small amount of vacuum and it will remove all the gases from the bitumen. So once they remove all the gases, now the bitumen can be tested for further testing or it can be stored for later testing. So this way the components of PAV has been designed to simulate the long-term aging which will be happening in the field conditions.